In this video, I'll share some additional information about the Object Attributes Baker tool from my Game Tools Blender extension, presented in no particular order. A lot was already covered in the previous video, so feel free to check that out first. Alright, when baking attributes like position, rotation, scale and so on, most of them come with extra options that can be useful in specific cases, namely the reference and source options. Most of the time, world and self are what you'll want to use. Reference does what the name implies, it defines the reference point. Baking a position relative to the world is usually the common approach. It bakes the object's world position in Blender, which becomes the object's local position once exported to Unreal, meaning it's relative to the static mesh's origin, and that's perfectly fine. You can also choose to bake an object's position relative to its parent. Essentially, that will bake the position delta between the two objects. If the object has no parent, it falls back to the world reference. This can be useful when baking attributes into 8-bit textures, as it may reduce the range of values and thus improve precision. Using this method, an object's world position can be reconstructed in the shader by hierarchically summing each object's offset from its parent, starting from the root's position. The source option is also worth noting. Most of the time you'll be baking the attributes of the object itself, either relative to the world or its parent, as just explained. However, you can choose to bake the parent's attributes instead, or the grandparents, or the great-grandparents, and so on. These can obviously lead to unexpected results. For example, if you bake the parent's position relative to the parent, it will likely return a 0 position, so you need to be careful with how you set this up. Another option is to provide a custom object whose attributes will be baked. I don't expect this to be very useful, since it will bake this custom object's position for all selected objects. It acts as a global override. But who knows? A more interesting feature is the property option. An object can use a custom property by default named source object, though you can change this to point to a target object. This can be handy for baking things like a target rotation to interpolate toward. I'll go into more detail on that in the next video. Again, world and self are the most common use cases. Most attributes can be remapped into a 0 to 1 range. You'll then need to remap them back to their original range in the shader using the reported offset and range values. Remapping is often required when storing data in 8-bit textures to reduce memory usage. Some attributes, such as bit-packed quaternions, do not expose the remap feature because they can't. They actually require storage in 32-bit HDR textures. And that's pretty much it. When baking axes and extents, make sure to select the correct axis. If in doubt, display the object's axis in the viewport. When baking hierarchy data, the depth setting indicates which parent's index to bake. A depth of 1 means the immediate parent, 2 means the grandparent, and so on. 1 is usually the right choice. Now, storing indices in 16-bit floats is only accurate for the first 2048 values. To overcome this limitation, a special bit packing algorithm was developed by Jonathan Lindquist at Epic back in the day. It converts a 16-bit integer's bits into a 16-bit float in a way that allows it to be losslessly converted to a 32-bit float and back, allowing up to 30,000 unique indices to be stored in a 16-bit HDR texture. If you're working with fewer than 2000 objects, it can theoretically be disabled to save on the cost of unpacking the indices, though this cost is negligible. It's just a few cheap bitwise operations. If you're working with no more than 256 objects, you can use 8-bit encoding to store indices in an 8-bit texture, reducing memory usage even further. When in doubt, leave this option enabled and use 16-bit HDR. Limit depth is a useful feature that treats objects too deep in the hierarchy as part of their parent, as if merged with the parent's mesh. The filter selection helps you visualize which objects will be treated this way. For performance reasons, it's not recommended to use a depth greater than 3. That means trunk, branch, twig, and leaf. Thus, this setting is enabled by default with a depth of 3. Okay, there's not much to say about the mesh panel. Scale can be adjusted, axis can be flipped, and axis swizzling is supported. The default settings work well with Unreal Engine. You'll also most likely want to preserve the original materials, and you'll also likely want to duplicate the selection and merge the result to generate the baked object. If not, you can bake the attributes directly onto the source objects if you need to tweak them further. But be aware this can lead to unexpected results, especially if objects share data or have modifiers. And I feel like the rest is pretty self-explanatory. Now, a quick word about performance. I'm assuming you'll be using this tool to replicate a Pivot Painter style setup. Pivot Painter is great, but its performance cost should not be underestimated. It requires many texture samples, some of which are dependent on each other, leading to wasted GPU cycles waiting for those fetches. On top of that, it likely involves a fair amount of trigonometry to apply rotations hierarchically, often twice to fix the normals. Reconstructing a deep hierarchy, say with 3 dependent texture fetches, is generally considered expensive. For best results, try to limit the hierarchy depth to 1 or 2. But you do you. When in doubt, profile your setup and make smart decisions based on actual performance.